Serengeti, where survival is decided in seconds. A crocodile jaw breaks the water surface. A lion pride closes the encirclement in silence. A solitary buffalo registers its positioning error at the exact moment correction is no longer possible. Africa does not punish the weak. It simply does not tolerate being one interval behind. More than 1 million animals are moving through this ground right now. Not from courage, because stopping is death. Every stride is a calculated risk. Every lapse in sensory attention is an open window for what is waiting in the grass. The Serengeti does not assign sides. No permanent victor. No species granted exemption. Only pressure. And the single question every animal here must answer every day. Adapt or disappear. There are no heroes here. Only more than 1 million wildebeest, 300,000 zebras, and 400,000 gazelles moving in the same direction. Not by choice, because remaining stationary is the equivalent of death. This is the largest terrestrial migration on Earth. And it is not a journey. It is a biological filtration system operating continuously without interruption across every kilometer of this grassland. These species share no common language, no formal alliance structure, no shared leadership, but they share something that outweighs all of those variables combined: obligate biological compensation. Wildebeest carry olfactory and auditory systems ranked among the most sensitive on the savanna. They register ground vibration at distance, the acoustic signature of a distant water source, the movement pattern of another herd. The approach of a threat traveling below the surface of dry soil. But the short cervical structure and cranial geometry of the wildebeest imposes a severe restriction on visual range. They detect clearly what the eyes cannot locate, but cannot scan a wide enough arc to identify a threat approaching across open ground at distance. That is the functional reason zebras exist in direct proximity to them. Zebra eyes provide a visual field approaching 360 degrees, with near total elimination of blind spots. In tall grass, the zebra operates as a mobile surveillance system for the entire migration mass. Continuously scanning all approach vectors while the wildebeest processes ground-level and airborne sensory data. When a zebra detects anomalous movement and initiates flight, the entire surrounding mass responds without delay. No confirmation required. No secondary signal. This is not an idealized cooperative arrangement. No individual in this system is making a behavioral decision to protect the other species. These are two separate sensory systems operating in parallel within the same spatial zone. And the outcome is a living defense network that neither species is capable of constructing independently, but that network has defined limits. Old, injured, or juvenile individuals that cannot sustain the locomotion rate of the main herd body begin to fall behind. One step at a time, 100 meters at a time, until the separation distance is large enough to produce a signal that no predator on this savanna ignores. No mechanism within the system reverses direction to hold position for a single individual. The migration does not adjust its speed for one animal. It continues forward, and what is left behind becomes the next input in the food chain within minutes. This is the coldest operational logic in the natural world. The system persists precisely because it continuously eliminates its own weakest components. The migration does not preserve all individuals. It filters every day so that what remains is incrementally stronger for the next. And ahead, where the grassland ends and open water begins, that filtration process becomes more absolute than anything the land has produced. The herd stops at the bank, not because the threat has been visually identified, because a biological signal encoded across millions of years of selection pressure is pulling against forward movement. An ancestral marker older than any retrievable memory, registering that this turbid water is not their operational environment. Ahead is the far bank. Green grass, fresh water. Below the surface is what produces no detectable signal until the contact interval has already closed. The Mara River is the point where every physical advantage accumulated on land undergoes complete structural failure. Speed loses mechanical effectiveness in fast-moving current. Formation integrity collapses as each individual is forced to process independent hydraulic pressure. The zebra's 360-degree visual field is neutralized by turbid surface reflection. The wildebeest olfactory system cannot read the chemical signature of a predator that has been motionless under cold water for several hours. The entire cross-species defense network, built across thousands of years of selection pressure, disintegrates across a few dozen meters of water. The Nile crocodile was already here. It always is. A species whose evolutionary lineage extends back more than 200 million years. A body plan that has undergone negligible structural modification since that point, because no modification was required. Up to 20 feet in total body length, up to 2,200 pounds of body mass. The crocodile does not pursue prey. It does not need to. It waits until the prey self-delivers to the contact zone. In a river crossing, the prey has no available behavioral option except self-delivery. When a wildebeest enters water deep enough to limit ground contact, the distance remaining to safety is no longer measured in meters. It is measured in seconds. The strike produces no warning interval. The water surface fractures. The jaw locks onto a leg or muzzle. The death roll initiates immediately. The crocodile does not apply linear force to hold the prey in position. It rotates the full body mass to generate torsional loading, which disables all muscular resistance in the prey within the initial rotation cycle. Large wildebeest occasionally break free when the initial lock fails to achieve a mechanically optimal grip position. But escaping crocodile contact in fast current with the muscular system already at anaerobic threshold does not produce survival. The individuals that reach the far bank do not look back. There is no behavioral processing of the event, only continued forward movement, reintegration into the herd mass, continued migration. The Mara River does not apply the savanna's distinction between strong and weak. Here, the only variable separating a living animal from a dead one is the timing of the water entry. Earlier or later, this position or the adjacent one, this second or the one that follows. Not physical strength, not speed, only timing. And timing is not a trainable variable. On the open savanna, not every prey animal waits for outcome assignment. African buffalo do not default to immediate flight as a first response. They hold position. And that behavioral fact is why even a lion pride must complete a full risk calculation before committing to an attack on a stationary buffalo formation. A mature African buffalo carries a body mass approaching 2,000 pounds. The hide thickness across the dorsal and lateral surfaces provides passive ballistic protection. The cranial bone structure at the horn base has fused into a continuous dense shield, a formation capable of absorbing direct impact force that would produce structural failure in the skeletal system of most other large species. When a buffalo accelerates to 31 miles per hour and drives its full body mass into a single contact point, the resulting force approaches 1 ton of impact loading, sufficient to project a mature lion into a full aerial trajectory. But the physical capacity of the individual animal is not the primary threat variable in this species. When the herd consolidates, it forms a collective defense architecture that virtually no predator on this savanna will challenge from a direct frontal approach. Females and juveniles concentrate in the interior zone. The largest males, heavy black body mass, wide horns spread, dried mud compacted across the dorsal surface as a natural armor layer. Form the outer perimeter ring. Heads oriented outward. Inter-individual spacing tight enough to prevent any gap, wide enough to isolate a single animal. This is not random spatial distribution. This is a synchronized response that activates when threat recognition crosses threshold. Without any vocalized signal, without any individual coordinating the formation, in Zulu cultural tradition, the buffalo is not classified as prey. It represents the principle of unconquered resistance. Traditional Zulu military tactical doctrine incorporates direct structural influence from the buffalo's circular defensive formation under encirclement conditions. That is not coincidence. It is multi-generational observation of a collective defense architecture that demonstrably functions. But that architecture has one identifiable structural weakness, and the predators on this savanna identified it a long time ago. When an individual separates from the herd formation, even by a few dozen meters, even for a few minutes, the full defensive structure of the herd no longer extends its coverage to that individual. The thick hide is still there. The horn structure is still there. The body mass is still there. But without the herd formation behind it, all of that represents only the physical capacity of a single isolated animal facing a predation system specifically designed to exploit exactly this moment of separation. And on the savanna, a moment of isolation is never ignored for long. Lions do not attack the buffalo herd. They attack the gap. This is the essential operational distinction between raw physical force and applied tactical method. And the lion prides operating on this savanna have refined that distinction across successive generations. A mature buffalo carries twice the body mass of a lioness and is capable of terminating a direct confrontation with a single forward strike. Attacking a stationary consolidated buffalo formation is a tactical option that no pride can sustain from an injury cost standpoint. So they do not. Lions are the only felid with a stable long-term social structure. And that structure does not exist for social function. It exists because collective hunting provides access to prey categories that no single individual can bring down alone. Lionesses are the primary hunting force within the pride. Smaller body mass than adult males, but higher top speed, greater lateral mobility, and superior coordination capacity in confined spatial conditions. When targeting buffalo, they are not locating the most physically dominant individual. They are locating the individual in the wrong position. When the separation distance reaches the threshold, the attack initiates. But even at that point, the sequence does not terminate quickly. Buffalo do not go down fast. They fight back, engaging with forward strikes, lateral body rotation, using body mass to generate counter-impact. Lionesses use retractile claws to maintain dorsal and lateral attachment points, staying out of the high-risk frontal zone, extending the attrition interval until the prey's muscular output drops below the threshold required for the throat lock to be applied safely. This is not an attack. This is attrition management, a sequence engineered to be won by degrading the opponent's physical output before the terminal strike is attempted. but occasionally the calculation fails. Occasionally, the sequence extends long enough for the distress signal to propagate back toward the herd. And when the buffalo herd reverses direction, the complete tactical geometry of the confrontation inverts within seconds. The ground registers the displacement before the animal enters the visual field. Not seismic activity, only 13,000 pounds in motion. And when the mature African elephant steps out from the tree canopy, every surrounding organism recalibrates its spatial behavior in response. Gazelle herds open a lateral corridor without being driven. Zebras alter their heading without looking back. Even a resting lion pride relocates if the elephant group's movement vector is directed toward their position. This is a category of power that is entirely distinct from anything else that has appeared on this savanna. A mature African bull elephant carries a body mass of up to 13,000 pounds and stands up to 13 feet at the shoulder. Each footfall generates ground pressure detectable through the substrate at a range of dozens of meters. No natural predator on this continent has the physical capacity to engage a healthy, mature elephant. Most predators on this savanna have learned that fact through an experience they did not repeat. The trunk is one of the most mechanically complex structures produced by any mammalian species. It contains more than 40,000 discrete muscle bundles. No internal skeletal support. It can extract a full-grown tree from the ground by the root system, or retrieve an object smaller than a coin from a flat surface without damaging it. In a defensive context, the trunk, combined with the tusk structure, generates force sufficient to invert a loaded utility vehicle. But the variable deployed more consistently than either the tusk or the trunk is considerably simpler: body volume. When an African elephant turns to face a threat source and extends both ears laterally, the total projected body surface area nearly doubles, producing a biological barrier that very few predators on this ground have the reflex capacity to advance toward. But physical mass accounts for only half of this animal's operational profile. Long-term memory in African elephants is documented through direct field observation. They retain spatial knowledge of water source locations across multi-year intervals. They recognize individual animals encountered decades earlier. They transmit territorial and threat information to subsequent generations through behavioral observation and direct social learning. The herd follows the oldest female, not the largest, the most experienced. When dry season conditions eliminate surface water from familiar zones, the matriarch leads the herd to water sources she has accessed across previous drought cycles. When a threat is identified, the group's response is shaped by the individual with the highest available information density, not the individual with the highest body mass. This is a combination that no other species on this savanna produces. Physical mass sufficient to eliminate most predation pressure, integrated with an information processing system, sophisticated enough to navigate the pressure that remains. Elephants do not need to engage in frequent conflict. Unassisted presence alone is sufficient to restructure the behavioral patterns of every other species in the surrounding area. There are not many species on this savanna that a lion identifies at distance and then actively routes around. The rhinoceros is one of them, not because of speed, not because of social intelligence or coordinated tactical behavior, but because when a white rhinoceros carrying 3,100 pounds of body mass commits to a direct charge toward a threat vector, very little on this ground has the structural capacity to absorb that collision and remain functional. Rhinoceros hide thickness is sufficient to prevent the majority of predator bite attempts from penetrating the lateral body wall. The horn, composed of densely compacted keratin, the same base material as human fingernails, but orders of magnitude denser, is not an active offensive instrument. It is the terminal force concentration point. When the animal drives forward. At 31 miles per hour, with more than 1 ton of body mass directed into a single contact point, the resulting force is sufficient to overturn a passenger vehicle. But that formidable defense system operates on a sensory platform with defined and significant constraints. Rhinoceros' visual acuity is poor enough that the animal cannot resolve specific shapes clearly beyond approximately 100 feet. The visual world of the rhinoceros is a field of indistinct shadow forms and movement signatures, sufficient to trigger a response, but insufficient for accurate threat characterization. This means rhinoceroses sometimes charge objects that present no actual threat, and sometimes fail to detect a genuine threat approaching from a favorable wind direction. Olfactory and auditory systems compensate substantially for the visual limitation. The rhinoceros nasal system detects chemical signatures at ranges significantly beyond its usable visual distance. This is the primary sensory channel used for environmental assessment. When an unfamiliar olfactory or acoustic signal appears and the visual system cannot confirm the source, the rhinoceros' default response is to charge toward it, not because the species operates with excessive aggression, but because in an environment with restricted visual range, committing to a forward charge toward a potential threat and resolving it quickly is a safer operational strategy than waiting for additional sensory data to arrive. Rhinoceroses are solitary animals. That solitary existence generates a specific category of pressure. No collective alarm network, no conspecific compensation for individual sensory limitations. Each individual operates as a fully independent unit. And territorial contact events between conspecific individuals produce intraspecific mortality rates that are unusually high relative to most large mammalian species. But the most significant threat to the rhinoceros does not originate from within this ecosystem. The keratin horn structure, which carries no particular biochemical value and is chemically no more complex than a fingernail, has driven this species to the edge of extinction through external market demand. Poaching activity has eliminated entire black rhinoceros populations across multiple regions within a few decades. What 50 million years of evolutionary development produced, the hide thickness, skeletal architecture, and defensive reflexes, has no functional value against a projectile fired from a distance beyond the animal's usable visual range. Preventive dehorning programs and active protection patrols are slowing that process. But this is the first interval in the evolutionary history of this species where the primary threat is not a component of the natural system. It originates entirely from outside it. That neck was not produced solely to access elevated leaf material. The giraffe cervical column extends to nearly 6.5 feet in length. But within that structure, there are only 7 vertebrae, the identical count present in the human cervical spine. The difference is that each vertebra measures more than 10 inches in individual length, and the entire skeletal framework is encased in dense muscle mass sufficient to absorb and generate impact force that few biological structures of comparable scale can match. To drive blood upward through that full column length to the brain, the giraffe heart weighs up to 24 pounds and generates arterial pressure approximately double that of the human cardiovascular system. This is one of the most powerful cardiovascular systems produced by any mammalian species. And that entire system, during the reproductive competition period, becomes a weapon. Necking, the behavior in which 2 males use their necks as impact instruments against each other, is not a symbolic display. This is actual combat with actual physical consequences. When a mature male giraffe swings the full cervical column and drives its ossicones, Genuine bone projections emerging from the cranium and covered in skin and hair into the lateral body or limb structure of the opponent. The resulting force is sufficient to fracture ribs, produce internal organ trauma, or render the opponent unconscious immediately. The acoustic impact of the contact carries several hundred meters across flat grassland. The most intensive bouts terminate with one individual on the ground. Unable to regain standing posture immediately. In documented cases, the cervical column has sustained complete structural fracture. This is a complete biological paradox, a structural feature that evolved to access a food source outside the reach of competing species. A pure survival advantage has become the decisive weapon in intraspecific conflict. The same cervical column, the same muscle mass, the same arterial pressure continuously generated by the largest heart on the savanna, serving two entirely different functions depending on the behavioral context. The giraffe is not a species that engages in frequent conflict. In the majority of interactions, their presence on the grassland projects stillness and deliberate movement, feeding at height, observing from an elevation no other species can access. But when conflict occurs, what reads externally as elegance and proportion can terminate a confrontation within a few contact cycles. On the savanna, morphology never serves a single purpose. The jaw opens, and that is not a yawn. When a hippopotamus opens its mandible to 150 degrees and exposes lower canines measuring up to 24 inches in length, this is a signal that requires no interpretation. This is a boundary marker, and crossing it is a terminal error. Not a ritualized display, not a formal behavioral exhibition. This is the final warning output before contact violence initiates. And the hippopotamus does not issue many warnings. The hippopotamus is documented as the most dangerous large mammal on the African continent. Not the lion, not the Cape buffalo, not the rhinoceros. Annual human fatality figures attributed to hippopotamus contact exceed those of any other large species on this landmass. The reason is not that the species actively seeks conflict, it is that the species does not accept territorial incursion in any form. The lower canines of the hippopotamus serve no feeding function. The hippopotamus is a grazing species, and the upper jaw handles vegetation processing. The lower canines are purely offensive instruments, maintained in a continuously sharpened state through a self-honing mechanism that operates each time the jaw closes. No external maintenance required. No degradation over time. The cutting edge is restored automatically with each occlusion cycle. A single bite from a mature hippopotamus is sufficient to bisect an adult Nile crocodile. But the primary threat variable in this species is not the canine structure or the body mass. It is the absolute territorial logic that governs all behavioral responses. There is no concept of shared space in the hippopotamus behavioral system. The water zone, controlled by a dominant bull, is that animal's exclusive territory. No negotiation, no exception based on the body size or species identity of the intruder. A kayak that drifts into a hippopotamus control zone receives the same response as a crocodile that has approached beyond the tolerance threshold. The physical scale of the intruder does not alter the response. Only presence within the control boundary is the determining variable. Externally, the hippopotamus rests motionless below the water surface with eyes partially closed, or stands on a mudflat in a posture that produces almost no visible movement. There is no continuous low-level threat signal, no sustained vocalization, no long-range approach behavior, only the dense, motionless silence of an organism that has nothing remaining to demonstrate until the boundary is crossed. When everything ends on the savannah, the actual work begins. The lappet-faced vulture, the largest vulture species on the African continent, descends on a wingspan approaching 10 feet and casts a shadow across the carcass before the feet make contact with the ground. No other scavenger species on this continent approaches while it is still standing there. Not from fear of aggression. But because no other species present carries a bill with sufficient mechanical strength to accomplish what the lappet-faced vulture is about to do next. The hide of an elephant, a Cape buffalo, a rhinoceros, the thickest integumentary layers available on this savanna, cannot be opened by the majority of scavenger species. The lappet-faced vulture can open them. Its hooked, heavily reinforced bill drives through thick hide, opening access to the interior tissue that the entire scavenger tier below it has been waiting to reach. This is a non-substitutable ecological function. No other species in this system fills that role. When the lappet-faced vulture begins feeding, the signal propagates outward in multiple directions. Smaller vulture species, ripples and white-backed, have been monitoring from distance and begin their descent. Jackals approach from the perimeter. Hyenas register the acoustic and olfactory signature and begin directional movement. A carcass on the savanna does not remain undisturbed for long, and its decomposition does not occur randomly. It follows a strict, tiered sequence in which each species arrives at the correct interval and processes the specific tissue type that its own anatomical structure was built to handle. This system is not direct competition. It is functional division of processing roles. The smaller vultures cannot open thick hide independently, but can access interior soft tissue faster than the lappet-faced vulture once the initial opening has been created. In the reciprocal direction, smaller vultures in large numbers locate carcasses faster from altitude, and the lappet-faced vulture monitors their aerial behavior to locate food sources at range. Both depend on each other without any direct behavioral interaction required.